Okay, so now what we're going to do is we're going to put all the pieces together, all the things that we've studied so far in this unit. We started off with solving equations, and those are really just for developing some of the skills that we need to determine values of x and y when we're solving, and how to substitute values in for x and y. Then we looked at some linear patterns with shapes and maybe a little bit of nonlinear, but our focus is linear. And we also put those into tables and even into some graphs. So now we're going to look at some real linear applications. And when I say linear, that means that the slope is always going to stay the same. We always have the same rate. A classic example of that is with a taxi car company. Okay, a taxi car will charge its customers usually by a rate that has a starting amount. So notice it here, it says this NIT taxi charges a fare that has an initial starting amount of 70 peso. So that initial starting amount of 70 pesos, I'm just going to highlight that, okay? So that's what we're starting with, and then plus 30 pesos for each additional kilometer, okay? Whenever we have a linear function, we are always going to have an independent and a dependent variable, okay? We're always going to have an input and an output. So remember here, this is our x value here. This is our input. So I can put that here. That's our input. The input is the independent variable, and the output depends on the input, okay? So it depends. That's our y value. This is the output, right? This is the dependent variable. I don't need to write that, okay? So that's our y value, okay, on the graph. Let me go ahead and label the graph here. So we have our y-axis here. In this case, this is going to be the fare. And that's going to be in peso, right? That's our unit. Down here, this is our input. This is going to be the number of kilometers. This is our x coordinate, right? And this is just going to be, well, we can say this is 5, 10, and 15 kilometers, right? The fare is in peso. So let's say that we have it here is like 100, then 200. Hopefully we don't get too expensive here on this scenario. 300, and then we'll put 400, okay? So that should get us most places that aren't too far from the airport, for most of us who live in Manila. All right, so what is the initial amount? That is, we call that, that's our starting amount. That's also called a y-intercept. And we'll talk a little bit about why that is the case, okay? And then our rate, or the slope, is 30 pesos for each additional kilometer, okay? So what's that going to look like? The fare, and we're going to practice writing these equations, right? There's only two things we need to look for. What is the rate per input? In this case, x is the number of kilometers, okay? And I did put that here as well, okay? So let's just talk about what if we had 0 kilometers, right? If we were to travel 0 kilometers, we have to pay the initial 70 plus how much per kilometer? 30. But that's going to be 0 kilometers. So the initial starting would be, if we had 0 kilometers travel, we would pay 70 pesos. Okay? And I'm going to plot that point. I'll do that a little bit later. If I was to travel 1 kilometer, I would say, okay, well, that's going to be 30 times 1 plus the initial 70. So that would be 100 peso. That's 100 for 1 kilometer, okay? If I travel 2 kilometers, that would be 30 times 2 kilometers, right? Plus the 70 that we had to start with, that's 130. If I go 10, that's 30 times 10 kilometers. That's 300, right? Plus 70. That's going to equal 370. And then this one, 30 times 13. Whoops, that didn't work too good. So 30 times 13 kilometers. So that's 390 plus 70. Whoa, that's a lot. Okay, is 460. Okay, that won't even fit on our graph. Forget about that. All right, so what is it for X amount? Well, we're multiplying the rate, or the slope, is 30, right, times the number of kilometers. So if the number of kilometers is X, we would have to times it by X. X just represents the number of kilometers, right? Plus 70. So this is our function right here. This is the linear equation that represents the scenario. So the fare is equal $30 for each kilometer, which we called X, plus the starting amount of 70. Okay, and I'm going to label these. This is the starting amount, and this is the rate, or we called it slope. Okay, the reason we call it a rate is in a real application. We'll say, what's the slope of the taxi fare? No one says that. They're going to say, what is the rate? Okay, so now we can go ahead and graph this, and I'm going to talk about why we call this starting point is also called the y-intercept. It's called the y-intercept. Okay, where is 0? This is 0, 70. That's the coordinate, right? So 0, 70. Okay, I hate that when that happens. All right, 0, 70 is right here, and this is 75, so I'm going to put it like right around there. So this is at 0 kilometers. Now, why is that the starting point? Why is it called the y-intercept? We know why it's called the starting point. Because that's where it crosses the y-axis, because the input is 0. The x value is 0. So that is where it touches the y-axis, which only happens once, okay? Another point we could say is 100. Okay, that didn't look too nice, but right here is 100. Okay, I'm going to skip to the 10, which is 370. So 10, and then 370 is like up here somewhere. That's 375, so I don't know, like right there. Okay, and what I can do is I'm going to insert a line. Okay, and since it starts at 0, okay, let's see, I'm going to start right here, and oops, that's what happens when you have, okay, so that's something about roughly what it should look like. That represents whatever the fare is, okay. So I'm just going to label this function. This is y equals, remember y is the fare, okay, because I said that right here. The fare is equal to 30 pesos per kilometer, right, x, plus that starting amount, which was 70, okay. So I'm going to go through some examples for IXL where I'm going to have you read some scenarios, and then you're going to have to create what is the function. Only two things we're always looking for. What is the rate? Okay. And what is the starting point? Starting, right? So the rate might have to do with a price of something. It might be related to time. Like what is the distance that you travel per second? Or per hour? What was the starting amount of time? Okay. It could be related to the cost of apples. So when you buy a box of apples, you have to pay for the box, okay? And then you have to pay so much per apple or something like that. Now sometimes the starting amount is 0. So in that case, you would start here and you would start that way. So if that was the case, if it was a taxi company that only charged 20 pesos per kilometer, you would have something like y equals 20x. And the starting point is 0, so you don't need to say 0. You just leave it blank. Okay, so you'd say, I don't need to put that there, okay? So that's just another example I'm trying to give you, okay? So let's take a look. I'm going to give you a little quick hint if you're having trouble with the IXL video, and you can take a look. I'm going to go through some examples with the IXL. This note, if you want it to print out, I have a blank template of this. You can print it out and you can do it, or you can do this in your notebook and put it in there, however you like.